Okay, here we go. We're going to do some Boris go up, please. I would like you, we're going to practice using derivatives to figure out when I've got mins and maxes on things. So, I would like you to take the function 4x cubed minus 12x squared and find and justify any relative min or maximum values, or any minimum or maximum values. You can give me just the x values. You don't have to give me the y values. There are two ways to do this. First derivative test or the second derivative test. I think most of you probably prefer the first derivative test. So, hit pause, give it a shot. Okay, I'm going to slide over to the answer so you can check your answer, and I will talk through the whole thing. Whoop. Okay, so you should have pretty much all of the work that I have here. We get a max at 0. You want to make sure you have this statement because f prime goes plus to minus. And a min at x, there should be an equal sign there, equals positive 2 because f prime goes minus to plus. So I'll walk through what I did here. If you got that and you are totally good with this, then you can just go on to the next timeline spot based on what I put on the Google Doc, right? You can skip forward to the next problem. But if you want to listen to me talk about it, then that's fine too. So I started with f as I gave it to you. I took the derivative. It was just some power rule. I then factored that. I set the derivative equal to 0. I factored it. I got 12. I pulled a 12x out of it, and I was left with an x minus 2 on the inside. So what values of x make this thing 0? X equals 0 and x equals 2. From there I went over and made this chart. And now remember, the AP won't give you points for this chart. This chart is just a way for us to organize our thoughts and to visualize what's going on here. So I got an x row, I got an f prime row, and I got an f row. So on my x row, in my x row, I do intervals that start and end. Start at negative infinity, right? And then go up to the smaller of these, and then in between the two, so that's negative infinity to 0, and then 0 to 2, and then 2 to infinity. Then I test f prime. I use this one, right? So for example, let me test this one right here. What would I do? I would take that guy, and I would plug in x equals, what's the easiest number in between 0 and 2? We're going to go with 1, right? So I get 12 times 1, and then, well, hold on, let me do it the way that we've talked about it a bunch. When I plug in 1 there, I just get a positive number, right? This whole term is going to be positive. Times, what do I get for this term? A negative. Plus times a minus, well, that's a minus. So that's where this guy right here comes from. And that's what I do for all of these spots. Anyway, from there, if the derivative is positive, then I know that the function itself is going up. If the derivative is negative, the function is going down. Positive going up. And then this helps me see, oh, I got a max. Oh, I got a min. So then I go and I make these statements, because these statements are the things that are going to get me points. Max at x equals 0 because f prime goes plus to minus. Min at x equals 2 because f prime goes minus to plus.
I see what says stop right there.
Yeah, I'm going to press stop right now, okay? Thank you. Okay, here we go. Next question. Same set of directions. I'm not going to write it all over again, but I want you to find and justify any relative minimum or maximum values for this function right here. So now your turn to try it, so go ahead, press pause. Give it a shot, and then in a moment I will walk through the solution method, same as before. Okay, I'm going to put the answer up in a moment. Okay, here it is. Hopefully you got the same thing that I have here. So I got a min at x equals negative 2 because f prime changes minus to plus, and a max at x equals 2 because f prime plus to minus. If you got that, and you agree with everything that I have here, then you're good to go. If you would like to listen to me talk through it, then feel free to do so. Alright, so I start with my function. I take its derivative. I just use power rule. I set it equal to 0. I like to think about this. This is a negative term right here, so I pop that over to the other side. It's just easier for me to keep all things positive if I can. So move that over there. I get 6x squared is 24. I divide by 6, I get 4. And this is where you have to be careful. I get plus or minus 2 when I do that square root. So some of you might have just gotten a positive 2, right? And that would lead to missing one of these critical values, critical points, critical values. I'm thinking multivariable. Anyway, so from there, we make our chart. Negative infinity to 2, negative infinity to negative 2, negative 2 to positive 2, and then 2 to infinity. I look at the derivative, I plug in values. For this one, I guess it's easy to plug them in here. If I plug in 3, for example, I would get negative 6 times 9. And I'm not even going to do that. I'm just going to say negative 6 times 9, that's bigger than 24. So this will be negative, right? So I get negative. When I plug in 0, because that's the easiest number here, this term just goes away and I get a positive 24, so it's positive. When I plug in, when I plug in negative 3, I get the same things same values that I would have gotten for this term with the positive 3, because negative 3 and positive 3 squared both give me that 9. So I get down, up, down. I could see a max, I could see a min. I have to make my statements. Boom, boom. Hopefully you feel good with this. And we'll move on to the next problem. Okay, here we go. Next problem. This one is an absolute minimum, absolute maximum value. Sometimes they call them, well, absolute extreme values, extrema. But I want to find them, and they give me a closed. They give me a closed interval right here, right? By closed, it means it's an interval that includes those endpoints, negative 1 and 3. Similar process, but almost less work. You need to make a chart where you test the endpoints. So hopefully that jogs your memory a little bit, right? So go ahead, give it a shot. Hit pause. And I'll go over now. So you may not remember this as much because it was a long time ago that we did this, but the answer is in red right here. A max of 8 and a min of negative 1. With this work, that's the complete answer. So what I do on this one is I start with the function. There's my interval. I find the derivative, 2x minus 4. I set it equal to 0. That gives me x equals 2. Then what I need to do is check all critical values within the interval and the endpoint. So 2 there is between negative 1 and 3. So that critical point is in the interval. And then what I do is these are x values. I test this. That came from the left endpoint. I test that. That was the critical value. I test this. This is the right endpoint. And then by test them, I mean I plug them into the original function. When I plug in negative 1 to this thing, I get 1, the negative squares out, a positive 4, and a 3, they add to 8. And then I do the math for the other 2 points, and then I just compare these guys, right? I want to know what is the biggest there and what is the smallest. So 8 is the biggest of these 3 numbers, so I have an absolute max of 8. Negative 1 is the smallest, so I have an absolute minimum of negative 1. And that's it. Okay. And that's that for that problem. So hopefully you're good with first derivative test stuff and absolute minimum and maximum test stuff. Going back to these guys, it's possible to do these with the second derivative test, which you should also know, but I think that these are more familiar for you, so we're going to stick with these for now. Anyway, hope you're doing well, and thank you. Bye.